This tutorial describes some of the basic aspects of the various renderings that one has in Hypercam. The simplest rendering is a stick rendering. This is convenient for drawing in, and one hardly ever wants to draw without using stick renderings. So the stick renderings have various options associated with them. These are described here. One can have thicker lines, if you like, very thick to reasonably thick. Probably that's not very useful in most situations. You can have stereo if you want, and you can stare at the molecule with your eyes crossed, trying to see these things in 3D if you like. One can use perspective drawings, which are not terribly common but are useful sometimes. If you have proteins, you can see ribbon structures by turning this checkbox on. You can see vectors on the atoms, either describing the normal modes or the current value of the gradient, if you like. The gradient has to be computed, or you have to have computed the IR spectra to see these. Wedges are associated with whether bonds coming out of the screen are going back, and you only see these wedges when you basically have put some stereochemistry onto a bond. If you, for example, take and use the Shift key while you click on a bond with the drawing cursor and the Shift key, what you'll get is a stereo bond, or like this, or a wedge as it's called there. And so this is if it's pointing out of the screen, it looks like that. If it's going back, it looks like this. And so you can determine some of the spatial relationships of these bonds by putting wedges on them like that. And if you turn off the display of wedges, then you won't see the wedges generally. So those are the basic options for the stick rendering. For ball and stick, or the next rendering is balls, or balls and cylinders. Balls just is not terribly popular because you really want to see the cylinder when you see the balls, probably. So this is sometimes ball and stick, but we call it ball and cylinders here. And there's parameters for the balls and parameters for the cylinders. The balls can be shaded or not shaded. Not shaded is often a convenient representation, because these spheres are, if you print these on a piece of paper, these spheres are infinitely sharp. They're metaphile spheres, not bitmap spheres, and so you'll get a nice crisp rendering on a printer with this rendering. It won't be bitmap, it will be a line drawing with this rendering. So again, the balls, the normal thing is to have shading and or highlighting, and you can change the radius of these balls in various ways if you like. So that's a ball and cylinders. Another rendering is the overlapping spheres, or the CPK rendering, and these spheres have van der Waals radii, and so that's a CPK rendering. Again, there are options associated with these overlapping spheres, only really whether you want shading or not on them. And again, this is useful rendering because when you do not have shading, you can use a metafile to put this at high resolution on a piece of paper, whereas with bitmap you are restricted to the resolution of the screen. So those are CPK overlapping spheres. Dots or dots and sticks are dot surfaces, which is useful in the sense that you can get some sense of the three-dimensional volume, but you can see through the dotted spheres into the inside and see the stick drawing. So those are basically working drawings. All of them are fast enough to do real-time rotation and everything, as opposed to ray traced images, which are really only for presentations and are too slow to do use for working graphics.